So welcome to the world of data. In this presentation, we will embark on a journey to the exciting world of data. We will learn how to organize information, unlock its secrets, and make it talk. Just like we use words to communicate, data scientist or programmer use a special language called SQL to understand and work with information stored in computers. So there are lots of information stored in computer, and we want to extract some information out of it. So I can give you a very basic example of, suppose all our customer data has been stored in bank, right? And if suppose the tax rate people wants to know who all are doing the transaction worth more than 10 lakh many times. So they will come to know if the transaction has been done for more than 10 lakhs, they will be more visible to know. I mean, they will be more visible by the tax rate people to find it out whether they are actually corrupt people or not. So everywhere the data is present. Forget about the computers. As and when we wake up in the morning, we collect data. We are surrounded by data. We collect information from the moment we wake up, from the things we eat for breakfast to the games we play with our friends. Data helps us learn new things and make decisions. Just like detectives use clues to solve mysteries, we can use data to discover hidden patterns. So it is everywhere, like data is present everywhere, and without knowing, we are collecting. So if I ask you what you ate in the morning breakfast, you will know. You will just do some simple processing. Okay, what I ate in the lunch, what I ate in the morning. Then I may ask you what you ate yesterday. So I am giving you some inputs to know what has been happened. Throughout the day, you might have collected a lot of data, or throughout the day, indirectly, you know many things. But I am just asking from that data, your memory is processing and just giving me the answer for what you ate in the morning or what you ate yesterday, right? So this is all seamless experience. You don't know that you have that data stored somewhere, maybe categorized, or I mean, as a human, we have something personal, we have something official, like office talks, office projects, and something at home, which place is kept where. So you know everything. It is all organized within your body, but you don't know. Similarly, the data, if I want to store in computers, I have to organize in such a way, if I want to ask something later, I will be able to get the answer. So let's talk about zoo. You're going to zoo and you wanted to show kids that there are lions, there are chimpanzees, there are monkeys. But imagine a zoo where nobody is organized and kept in different cages. They are all roaming here and there. It will take time for you to identify which animal or what to find a particular or specific animal your kid is looking for or you are looking for, right? So just like we organize animals in cages at the zoo, we need a way to organize data in a way that makes sense and is easy to find, because storing the data is not going to help you. You are storing it just to get some information out of it, some insights out of it, right? Now, how you are storing the data? You need something to hold the data, right? So just like a spreadsheet, you will have tables in the basic building block of SQL where the data gets stored. Now, how it is getting stored, let's see an example with this house. You have multi-storied house, and each house, each floor, you have given it for rent. And each floor is having kitchen, bathroom, your living room, your dining room, study room, office desk, office den, everything. And it is the architect designed in such a way that for all the floors, they will have similar hall area. They will have under each of the bathroom space, you will have another bathroom. It may not be possible because the way they design the pipes and all, it is all under one column. So each floor, you can consider it as a row, and each area where you have specific information belonging to all those three floors is called as column. Let me take another example. So we can create different columns to store the information about each animal. Suppose I have, okay, let me take an example like this. So I have animals table, which is containing the information of all the animals, what kind of food they eat, how many legs they have. I have taken very basic examples so that even a high schooler kid also can understand. I'm not going to the bigger table examples, which has been taken everywhere. So animal table, having the information of animal, what animal it is, what food it is, what food he eats or she eats, like it eats, and then how many legs it has, and what habitat it lives in. So if I am asking you, forget about SQL. If I asking you how many legs snake has, and suppose you don't have to use your mind, you just have to read this table. So what you will do, you will find out, okay, I am seeing snake is here and the leg column is here. So I can see snake has 0 legs, right? And if I am asking you how many legs the spider has, you will directly go and try to find the animal name. And then you are trying to go to that particular column to see how many legs a spider has. Similarly, if I am asking you what elephant eats, you will go and find elephant here. And then in that particular row, you will try to find it out which column I am asking. I am asking food. So you will go here and tell me that elephant eats plants, leaves, and fruits. So each row represents one animal. Each row is having one animal features or values. And each columns is having information about that animal. I cannot say lion information is stored here under this row, which is fish. It is not possible. So each animal is having its features or values in the same row. And each features we can call it as column. Food column, legs column, habitat column, or animal name column. So this is row and this is column. So this is how the data has been stored. Now, if I ask you, I mean, there are possibility that I no longer want to know about the habitat where they exactly live. So what I can say, okay, I want to remove this habitat column. So I am talking about we can manipulate the data. We can manipulate the table. So I can go ahead and remove the habitat column. I can add one more column to it. I can drop the table animal itself because I may no longer to work. I may not require to work on this animals. I may be required to work on something else. So I am just making you familiarize with these words. Adding a new column means adding a new, suppose I want to add a color column here. Say what color lion look likes, what color elephant look likes, what color monkey look likes. Okay. Now there is a new animal comes in, and he likes to eat lot of food, which is not getting fit in this particular column length. So suppose if I am defining a column length as 30 characters, because everything you have to tell in your mind, you have lot of memory, right? You don't say, okay, to store the value of food what I ate, I will store only in 10 digits or 10 characters. That is not happening in our mind. But in our database or in our tables, we have to tell how much memory it is going to occupy. So suppose in future, as of now, it is only allowing 30 characters to store the food. But in future, I want to store a bigger number of words. So I can say, okay, 50. So I can increase the length of the column. I can decrease the length of the column. I can play around all this. So manipulating the table, it's a bigger topic. How we do it and all, I can take it later. I am just giving you or familiarizing you with all these words. Now, why you might be thinking, why what this table I will make a use of. So imagine, as I said, in bank, I may be having my customer ID, I may be having my username, my password, though it will be encrypted. It cannot be seen just like you are seeing the habitat column here. It cannot be seen with the naked eye. But we need to store information. Now, if we don't organize the information properly, bank people may not be able to find it out the correct username and password for that customer, and they may not be able to validate when you try to do the login, internet banking login, and then it will mess up. It will say, oh, this is wrong password and all. Similar thing as I said, lion legs values is stored here. That is not going to happen. It is well organized, and if the organization is not done in this way, you will end up having issues. And why we do all these things is, with the data, when you have organized this properly, obviously you may want to fetch the data later. You, in your kitchen, you are having one cabinet where you are keeping all your lentils or legumes. But there is another cabinet where you are storing all your Indian masalas, right? So you have sorted it out that this place I am going to put crockery, this place I am going to put knives. But if you mix and match everything and somebody is coming and asking you to cook, you will not be able to find it. So everywhere the organization is needed, be it data or be it your kitchen, be it your library. So library also have multiple sections, right? So in each section, you will have fiction, non-fiction, horror genre, or multiple segregation of the books you need to do. Librarian has to do, so that if anybody comes, you can immediately find out that book and give it to the person who is in need. So SQL, what it is doing, it's a magic tool for us. It is helping us to find out the data. Just a minute. Yeah. So it is a magic tool working like it's a detective. You just tell your requirement. So I am going to a bigger library in Seattle, say, which has multiple floors. And so each floor has different kinds of books. I will directly go to the library and I will say, okay, I want a yellow color book. So that may not be the easiest way to find it. Suppose I say I want a fiction book having 3 fairy stories. And if I give more and more detail to them, the data which is going to come back, or the books which are going to come back for me, is easier to find it. So if I say, okay, I want a yellow color book, and I don't say about the author, what genre it is, and all anything, I am not specifying it. So he is going to return me thousands of books from which I may not be able to find the exact book which I am in need of. So I give filter conditions. I tell what all I need. You need 1 book, 2 books, you need articles, you need magazines. You specify what you need, and then you add filters on the top of it. So SQL is giving it is giving us a privilege to add those conditions, to add those filters, and it is helping us to find out what information we need it for insights or reporting purpose. Or as I said, if I am not clearly telling, the text reader person wants to know which all customers is transacting more than 10 lakhs daily. So if I'm not giving the daily figure of 10 lakhs, and then how will that person will give me the data? He will try to fetch all the data. He will say, just you wanted the employee information or you wanted the customer information, I gave you. But then somebody has to sit and look at the data and try to filter it. That is not possible. So SQL is doing it on behalf of us. So we just have to write simple queries. I am not giving you how we are going to run the SQL. I'm not telling you what all you need to install it and all. I'm showing you the bigger picture. Then we will take step by step, and you don't have to, just for practice, as of now, you don't have to install anything as of now on computer. Online, there is an editor where we can go and experiment all these queries and have a hands-on. So now there are some SQL queries example which I wanted to show. We will, as I said earlier also, we will look into all this later. What is this select? What is this from? All these clauses we will talk about. But in general, how the SQL queries will look like, and without knowing all of that, you will be able to write the query now itself. So as I said, if I want to know the habitat column, I just wanted to know only what all habitat exist in this table. Doesn't matter which animal, what food they eat, how many legs they have. I'm just interested in knowing how many habitats are there. So what I will do is, this is just a column. Okay, these are columns and these are rows. So I'm just saying, okay, I want to select habitat from, this is an animals table. Select habitat from animals. That's it. When the result will come, it is going to give you only this habitat column, nothing else. So imagine a case where you just wanted to know, or the customer wanted to know only the credit transactions they have done on their account, or maybe the debit transaction that they have done on their account, only the figures that they want. So they will just say, I want the credit column values in the reporting, or maybe the debit thing in the reporting. Got it? Any questions here?
Megha, this
Yeah.
is Amrita. I just wanted to ask, like a very basic question.
Yeah.
Like SQL, we can only use for manipulation of data, analysis of data. Do we create something from SQL? Like, do we able to create data from SQL?
Okay, so if I have 2 tables here, okay,
Mm-hmm.
say customer table or any credit related, loan related tables. So by joining those 2 tables, I can have another table created by SQL. Okay, so
Okay.
SQL is like, okay, suppose you have tons of customers in your bank database, right?
Mm-hmm.
And if I wanted, or very basic example I'll take. Okay, I'll
Okay.
talk about the analysis perspective, maybe
Mm-hmm.
for data scientist people. So I have
Mm-hmm.
all the cricketers data in my database. Okay, be it Kohli,
Okay.
Sachin, and for every year, be it any year, be it any day, be it any month, how many test matches, how many one day matches they have played, how many World Cups they have played, what was their diet. And you remember, right? Recently, I mean, not recently, Kohli switched from non-veg diet to, say, vegan diet. And people wants to know, okay, after following the vegan diet, whether his performance has been improved or not. And if it is improved, it is improved against Australia, or which team it has been improved. So by looking at this data, lot of analysis can be done. And in sports also, you have data scientists there to actually analyze each and everybody's data. So now you have all the cricketers' data. I wanted to know about
Mm-hmm.
only Kohli's, right? So what I
Right.
will do is, I have tons of cricketers. It doesn't matter what all other cricketers are. I am only interested in Kohli's. So what I will write, select star. It means I want to know all the information from, say, cricketers. Cricketers is the table where you have all the cricketers data. Now I will say, okay,
Right.
I want all the cricketers, but I want only for from the cricketers table, but I want only the Kohli's data, where the cricketer
Right.
name equal to Kohli's. So you created you created a window. Just imagine you are living a 43 floor building, and by looking at your dining table, you are just seeing a view from balcony. So you may be able to see only 5 or 6 floors. That is just a view, right? But actually it has many data. So this select query is actually creating a small view for you, where you are saying, okay, I'm only interested in this kind of a data. So you will create that data and keep it in a separate table, because you don't want to expose all your data to the person who has asked only the Kohli's data, right? Because there might be multiple data scientists in your team. One is working on Kohli's, one is working on Dhoni. So those two people have rights to see only their particular cricketer's data. So you will create a small view or maybe a select query and store it in a different table altogether, which will contain only Kohli's data, and you will give that table to the new person or the data scientist. You don't have to worry about giving the whole table to that particular guy, because you don't know what analysis or what will impact. He may become biased by looking at other data. You don't know, right? Because one's body is going to differently behave by following a particular diet or yoga or training, something like that. So we have been given just a view or a window for that particular table to the new person or data scientist. So you can create data by, you will have data, you can create data, you can manipulate data, you can do anything.
Okay, so as per my understanding, like we have a huge lot of data, but when we want a particular set of data from that data, but that is a creation here, right?
Yeah, so you can create a view, and you can view can have multiple permissions which you can give to those users who are using it. You don't expose your main table there. Or you create a temporary table or a backup table and give it to them, whatever way you are comfortable with. But you know, when you create view, there is an option you can refresh it, because Kohli's, okay, my meeting is going to end in 10 minutes. I think we are about to finish. It's fine. So when you are creating a view, you have an option to refresh, because Kohli is playing daily, and the new table which you have created needs to be refreshed. But when you create a view, you can say, okay, every night you go ahead and refresh it from the main table. So you don't have to refresh it manually. View will have an option to do that. So views also are different kinds of view, materialized view and non-materialized view. It all depends whether you want to store the views data, or you just always creating a window or peeking from the main table and giving it on the fly.
Okay.
I'll take this topic later at the end once I finish. Because I just
I got the basics of it.
Yeah. So now I want to see the animals who has 4 legs. So what I will say, select the animal from animals table. Animal is a column. After select, we will write the column name which we want. And after from, we will give the table name. And then from where, from animals, where will give you condition. So you are saying you want the animal who has only 4 legs. So you are saying select animal from animals where legs equal to 4. So who has legs equal to 4? Turtle, monkey, elephant, and lion. The result of this will be four animals: lion, elephant, monkey, and turtle. The rest, all others will be hidden. Okay? Because you are interested to know or do analysis only for the animals who has 4 legs. Yeah.
2 hours. 2.5 hours. 5 minutes.
Can you mute, please?
2.5 hours हो गया ना?
Shobit.
अरे.
Okay. So you want to know what do lions eat. So what you will do, as I said, you will go to the lions row and find out the food column. Okay. So you will say select food. You want to know what food lion is eating. So you are saying, I want to know the food which comes after select, and you are telling which table, and then you are telling, okay, animal should be lion. Got it? Or you can also say legs equal to 4. Whosoever is having legs equal to 4, what all they eat. Just for some other analysis purpose. It all depends on the requirement, how it comes. So whatever you want to select will come in the select clause. From where it is going to come is the table name. And what all condition you have to put. The tax rate person wanted to know transaction amount is greater than 10 lakhs, right? So the condition will come in the where clause. Now it can be one condition, it can be multiple conditions. Got it?
Yeah.
Okay, so I wanted to know what animals lives in forest. Now this is tricky, because if I say habitat equal to forest, there is no animal who is just living in the forest, because they are living in savanna and grassland also, right? So you cannot use equal to here. all other places we were using equal to. It's an exact match. But here it's not an exact match because they stay in other places also. They may found in forest, they may found in grassland, they may found in mountains. So what you have to say, okay, it can be like forest. So before, when you're using like, you can use percentage. So say before forest, whatever comes, it doesn't matter. Whatever after forest, whatever comes, it doesn't matter. I just need wherever the forest is, I want to know which all habitats has forest irrespective of wherever it is. So I'm just saying I want to know the animal from animals table where habitat is having forest. I'm not saying habitat equal to forest. If you say equal to, it will just find it out only in forest. But if you say like, it will find it out wherever it is. Got it?
Okay. So yes, this semicolon is in the language, right? We have
every statement can be ended with semicolon.
okay.
Yeah. If you are giving multiple, if you don't end with semicolon, but if it will work. But if you have multiple statements, then between those two statements, you will add the semicolon so that it will know that this is one statement and another one.
Okay. So
Okay.
completion of sentences will be done by semicolon.
Semicolon. What animals lives in grassland? This is similar to forest. Instead of forest, I had just kept grassland. Now I wanted to know animals who lives in forest and grassland both. So when I'm saying both and using an and word, it means it has to have forest and grassland in the habitat column, both. Now it can be possible I will have forest, grassland and savanna also. Doesn't matter. I just want forest and grassland. So I'm going to use an and keyword between those two statement, those two clauses. So where habitat like forest, wherever forest comes in, it doesn't matter. Wherever grassland doesn't matter, but has to have both. So for both, you will use and. And if I'm going to say or forest or grassland, so it can be either forest or grassland or can be both. So I'm going to use or keyword here, or. Okay. And is like both conditions should match. Or is like if any one of them matches, it's fine. I will show that record. Now, too much of data is overwhelming. Obviously, if you have a cluttered desk, you may not be able to find the file or the paper which you are looking for until you organize it. And how we have organized, you might be having multiple files. So you might be having multiple tables. So to have multiple tables, you are going to need a database. A database is what is containing lots of tables. So database are like digital libraries for information. Imagine a database like a library with multiple bookshelves. As I said, it can be divided with multiple categories as fiction, non-fiction, horror ones, and different suspense and other things. So a database is like a library where you have multiple bookshelves organized by the topic. So every database can have multiple tables. So it can be possible, it cannot be possible in bank, right? I can store all the information of customer in one table, all the information of loans in the customer table. It can be possible. There are some types of loans which has not been taken by any customer. So I cannot club all the information in one table. I have to have multiple tables to organize the data so that if I query, I will be able to find out quickly. So when you're ordering on Amazon, your order table, your customer table are not single table. They are different tables because order details needs to be stored differently than the customers. You might be having millions of customers, but it is possible. And all those millions of customers might have done thousands of transactions. So if you keep in a single table, it's not easy to, I mean, we will talk about the normalization thing in detail, but you cannot store all the information in one table is what you need to know now. So your database may be having multiple tables so that it is well organized and you can query it easily. So as I said, tables are like a spreadsheet inside the database. You will have columns and rows. We are just talking about the tables here, which we have already covered in the previous slide. And here we have just taken example of employees table having employee name, number, age, department, and salary. And this is a repeated slide. I just have to remove it. And then this is just a homework. We just need to find the employee information, all the employee information. So when I'm saying all the employee information we need, there is no where clause. So what we can say, select a star from employees. I am saying star, it means I want to know all the columns from the employee table, irrespective of what all they have. It is not like I'm adding a condition. So I think it is less than 1 minute. Meeting is going to end it. I'm going to share this deck. And we can cover this all 4 queries maybe in the next session. So this was just the basic SQL which we have taken, introduction. Each and every topic which we have discussed are going to come in detail, but we just wanted to, I doesn't want to get you all bored by going through the theory and all. That is why hands-on I have done, so that you will get an interest and you will learn a lot. So maybe next session we will continue and we will see how we can, in the online editor, we can run the queries and we can experiment. I'll share the
Thanks,
deck.
Meghna.
Thank you.
Thanks, Meghna.
Thank you for
Thank
your
you.
time. Bye-bye.
Bye. Good night.